We are now in chapter 10, the second topic in statistical inference, um, uh, construction of confidence intervals. Okay, remember, like at the beginning of chapter 9, we said x bar plus or minus m, which will give you this. Okay, so you can say with 95% confidence, you can say that the body weights of 20 to 29-year-olds will be between 180 to 186. Okay, all right. So that's pretty much what this confidence interval does. It gives you a nice range, where the unknown mu will be lying with a certain amount of um, assurance or confidence. Okay, all right. So let's go to the next slide. Okay, now there we talked about only 95%. There's nothing really magical about 95%, but 95% is default lots of times, but we can change it, especially because this is a biostat class. We should move away from 95 because, see, when you do a biostat, when you do experiments related to people's health, we are going to be more careful. So we may even need 99%, or maybe even more confidence. So because of that, let's see how that formula works, even if the confidence is not 95. So now this is actually symbols jargon here. So now this is actually 95. This whole business, 1 minus alpha times 100 is 95. So if this is 95, you can say that 1 minus alpha is 0.95, right? So 0.95 times 100 only will give you 95. So have this 0.95 is actually the middle portion of the normal curve. Okay. So now to get the confidence interval, you need to get the percentile, which is the left probability of that middle portion and the leftmost. So that means, see, if you think in a picture, the middle will be 1 minus alpha, the left side will be alpha by 2, the right side will be alpha by 2. So that, they will all add to 1, right? 1 minus alpha plus alpha by 2 plus alpha by 2 will give you 1, okay? So now to get this number, this is actually the percentile, okay? So to get the percentile, we need the left proportion. So left proportion will be alpha by 2 from the leftmost left tail plus the middle portion. So alpha by 2 plus 1 minus alpha will give you this. Okay. I really wish I could. I cannot do symbols here. Mm, no, but I'm tempted to do it. Alpha by 2, actually how it worked out is because it is alpha by 2 plus 1 minus alpha. Okay, so that is how you got it. And how did you get alpha by 2? This is actually the left tail proportion, and 1 minus alpha is the middle proportion. Okay, all right. So that is how you get that. So always, it doesn't matter if you have 99. This will be 0.99. Then the two tail proportions will be 0.05. So then this will work out to be like 0.995. Okay, we will do more problems, and then we'll see how it works out. Right now, if you are doing a 95%, this 1 minus alpha will turn out to be 97.5, because it is like this is 0.95, this is 0.025, then this will turn out to be 97.5th percentile. Okay, all right. So you can pause at this point and then look to see whether my arithmetic is correct. Okay, all right. So let's go to the next slide. Okay, so here they have given you like these are common confidence levels: 90, 95, 99. Okay, so if you have 90% confidence level, 1 minus alpha, remember without the 100 will be 0.90, then for 95 it will be 0.95, for 99% it will be 0.99. So if you have for 1 minus alpha these numbers, alpha would be, alpha level will be, work out to be 0.10, right? Because 1 minus alpha will be this. So actually 1 minus alpha are the middle proportions. See, that's why I put these arrows here. In fact, there can be another arrow going this way. I did not want to crowd the presentation or the slide too much. Okay, so 1 minus alpha would be this light blue shaded middle proportions. And then alpha would be the sum of these two, because 1 minus alpha will give you alpha. That will be this plus this. So that's what I have put in here. Okay. And then, so now what we need is 1 minus alpha by 2 percentile, right? So this plus this will be 1 minus alpha by 2. So we need to get this number. So this will be actually, like in this case, 95th percentile. Okay. So the 95th percentile, wait a minute, yeah, it will be the 95th percentile. You can look it up and see it will be 1.645. Likewise, 1.96 is the 97.5th percentile. In other words, this whole proportion, this little thing plus this will work out to be 0.975. That you can look up the bell curve, it will be 1.96. Now see, now you can see how you got that 2 for margin of error and also for the empirical rule. 1.96, they, have been approximated to 2 because 2 is a nicer number than 1.96. Okay. So, and then with 1.96, which is approximated to 2, will give you a 95% confidence interval, right? 95%. Okay, so for 99, likewise, to find this, you need to go, this plus this will give you 0.99, let's see, this is a mistake. Oh yeah, that's, wait a minute, this is correct. So 0.995, so that will be 99.5th percentile. Okay, so so this is like 99.5. When you add these two, you will get you will get 2.58. Okay, so that's how you get these the z values in the formulas you get by looking up the bell curve when the left probability is this plus this. Okay, so please go over it a little bit more carefully, so that you are very comfortable in how to get that z value. Okay, all right, so let's go to the next slide. Okay, so now in here, by plugging those numbers, we can get a 90% confidence interval. So actually 90% means, so then alpha would be alpha would be 0.1, alpha by 2 will be 0.5. So that is how you have 1 minus this is 0.05. Actually there should be I know you can see that there is like a point, but they should have put it as wait a minute, yeah, 1 minus let's see, so here let's work this out. Yeah, okay, I went back to check something. So 1 minus, this is 1 minus 0.05. 1 minus 0.05 will be 0.95. As you can, you can go back to the previous slide. Let me show you. In fact, I double checked. So it is 0.95. 90 plus 5 is 95th percentile, which is 1.645. Okay, so let's see. Let's go back in here, and that's how they plug this number 1.645 here, and then once you work the whole thing out, you will get this. Okay, all right, let's go to the next one. Likewise, they are doing a 95% here. The only change is 1.96. Only change is the z value. Okay, everything else remains the same. So let's go to the next one. And likewise 99%, they have they have got the z value, and then once you plug in, you get these. Now you can see that confidence intervals, that there are 3 confidence intervals that were constructed. They are quite different, except that the midpoint will be the same. Not exactly, midpoint will be the sample mean. Okay. And then okay, so let's see, let me go to so since the same information is used, only thing that changes is the x bar will remain the same. So all confidence intervals will have the x bar to be the midpoint, which is 183. Let me go to the next slide. Okay, right here. Okay, so now in a picture you have it. So you can see that all 3 of them have the point estimate, which is the sample mean, to be the midpoint. Okay, this is the sample mean. Actually, numerically it is 183. Now you can see that confidence intervals are getting wider as you increase the confidence. I mean, it should be intuitively clear. If you want to be 100% sure, you should include the entire real number line, right? If you include the real number line, for sure you know that the actual mean is going to be there, because the actual mean is some real number. But see, what's the point in that? The ideal thing is to have a narrower confidence interval and a higher confidence level, right? You need to say, okay, your warranty should be really, really high, and at the same time, your margin of error should be really, or the plus or minus part, okay, your plus or minus part, the gap, okay, should be much, much smaller. So ideally, you will like this to be high, this to be low. So it should be something like this, but something like that. Something like narrower confidence interval with a higher confidence level. Now, of course, they go in opposite direction. Only one way that you can have confidence interval to be narrowed down, and while the confidence level is high, is to have the sample size increased. So in other words, by increasing the sample size, you can increase the confidence level, but decrease the confidence interval width. And then both those are quite desirable. High confidence level and low interval width. Okay. Now sample size requirements. Okay. Now this issue comes up, when you are planning a study. Say you want to have the confidence interval to be some width. Okay. So now the width is actually this. Remember, this is actually the width of at least half the width of the confidence interval, right? And then, so if you want the width to be maybe 50 or whatever, you can plug this to be 50, and then, you can get the n value you want. Okay? All right. Okay, so in here, in fact, they have plugged those numbers. So you have a standard deviation to be 15. Now this S is an approximation to the actual standard deviation. Lots of times, if you have good amount of observations, the sample standard deviation is a very good estimate for the actual standard deviation, and you can plug that in here. Okay, and then see if you want a 95% confidence interval. Then you plug these numbers, and then you will get the sample size that you need. Okay. Actually speaking, margin of error, I mean, this is being used, but actually speaking, it's rather than smaller, I will say CI widths. Because see, the term margin of error is used only if you have 95. Since they used 95 here, it was okay to have margin of error here. but let's do CI with, so that because this term applies even if you have the confidence level to be something other than 95. Okay. Okay, now the last topic for this the lecture. Let me go back here. Yeah. Yeah, the relationship between hypothesis testing and confidence intervals. Now, this is the neat thing actually. Now, actually, when you start doing problems, you will notice that hypothesis testing is quite, it's a little bit more detailed than doing a confidence interval. Now, you can take a shortcut because of this. What it is saying is a two-sided test will reject the null hypothesis at the alpha level significance when the value of mu sub 0, remember this is the hypothesized value for a test, right? If that hypothesis value falls in that confidence confidence interval, then you can reject the null hypothesis. Okay, I mean this makes sense, if you think a little bit and do a couple of problems. In fact, in a picture this becomes quite clearer, much clearer. Let's see how this works. Okay, now only thing is, remember, we can create lots of confidence intervals, right? But see, this equivalence is true if you have the same alpha. So the alpha level of significance, if alpha equals 0.05, when you plug 0.05 in here, this works out to be 95. In other words, a two-sided hypothesis test with alpha equal to 0.05 can be, the conclusion of such a test can be deduced from a 95% confidence interval. Okay, so these alpha should be the same. The alpha that occurs in the confidence interval and the alpha that occurs in the hypothesis test should be the same. In other words, if you have alpha equals 0.05, you cannot use a 99% or a 90%. You have to use a 95, because with alpha equal to 0.05, this will work out to be 95, right? Because this is 0.05 means 1 minus 0.05 will be 0.95 times 100 will give you a 95. Okay, all right, so let's see. I talked a lot here, but anyway, let's see how this works. See, now here's the illustration. Now, in fact, we have been doing this hypothesis test in the previous presentation. We want to test whether the mean, the body weight was 180. And then say you were to test at alpha equal to 0.05. And if it is a two-sided test, you will have the you will reject H null if your mean is on this side or in that side, right? If you can remember, when we did our hypothesis testing lecture, we understood that. Okay, now, so you can calculate the test statistic, remember, and then you can do it that way. You can look to see whether it falls in this rejection, or look, you can do a confidence interval. Now see, this is a 95% confidence interval. The mu sub 0 is 180. Now look to see, is 180 in the confidence interval? No, because see, this confidence interval begins at 180.1. So that means the hypothesized mean is not in here. So that means you are rejecting the null hypothesis. You're telling that, okay, even by looking at the confidence interval, you can say that the mean is not 180. In fact, it looks to me as if the mean has to be somewhat more than 180, because the entire confidence interval is on the right hand side. Okay, all right. So now, of course, this equivalence is true if the alphas match. Here alpha equals 0.05, and then when you put 0.05, only you get the 95 here. Now, if you do a 99% confidence interval, here's the confidence interval. So now in there, the hypothesized mean of 180 is contained in the confidence interval. So if you look at the 99% confidence interval, that means, what does it say? The equivalent hypothesis test, the two-sided one, should have an alpha to be 0.01. Work it out. See, 99 means 1 minus alpha will be 0.99, so that the alpha will be 0.01. At alpha equal to 0.01, the conclusion for that two-sided hypothesis will be you need to accept h0, not reject. So depending on the alpha, you can see, you will make a different conclusion. In fact, that is why we discussed this. We will never be able to say that we are 100% sure. Remember, there was type 1 error, type 2 error, that kind of thing. In here, the type 1 error is much larger. Here, type 1 error is smaller, 1%. See, this alpha is actually type 1 error probability, right? Now, so if the risk is small, if you want to take a smaller risk, you have to go with the null hypothesis. Okay, so this illustrates two things, right? The equivalence between the two-sided hypothesis test and the confidence interval is true only if you have the same matching alpha, right? And the other thing that we realized is that, okay, you can, with the same data, you can reject, or you can come to different conclusions, either reject or accept h null based on different alpha values. So you may not get the same conclusion, or you may get, okay? So it depends on how strong the data is. Okay. Okay, so this is the last slide for this presentation. Actually, what I did, it's the same picture as the one in the previous slide. This, of course, you can see this in more detail. Okay. All right. So this is the end of confidence intervals. Now, from this point on, we need to pay attention to doing many problems. So we will be, in fact, I will have some problems written out, and then we need to pay a good bit of attention on those handouts that I will be posting pretty soon. Okay. All right. Now, by the way, chapters 9 and 10 presentations are now in the, actually they are in the website now.